Let's quickly take stock of where we stand. The first step in our timeline was to get set up on the Google Cloud platform. So we made use of Data Lab as a way to run Python code on Google Cloud. We experimented with getting data from BigQuery from a public dataset. Then we made use of our familiar estimator objects. Those are the high level APIs available in TensorFlow. We tried to predict the fare that a taxi trip in New York would take given the pickup and drop off locations and the number of passengers in the taxi. This is as far as we've gotten. We tried a couple of different model configurations. So we tried a linear regressor and then a DNN regressor. Neither of them performed very well relative to our rough benchmark. We then made a few small but significant tweaks to the code. We changed the manner in which we read the training data in so that it reads from files rather than from a pandas data frame. And we also changed the manner in which we specify the input columns. This would allow us in future to add feature engineering, that is to change the manner in which we compute the x variable values. We are now going to go ahead with yet another significant re-architecting. We are going to introduce an experiment object. The experiment objects, which are defined in tf.contrib.learn.experiment, are basically harnesses. These are ways in which we can evaluate a wide range of different models and save the best of those models to a particular location. Using the experiment framework also allows us to specify different export strategies for our models. And very importantly, when we use the experiment framework, it becomes easy for us to tap into the power of the cloud ML engine. That's something that we're going to turn to after this. We are going to make use of the power of distributed training. So we will drastically increase the size of the data that we use in training our model. That will make it impractical to train our model on a local machine. So we will switch over and carry out training on the cloud. This distributed training process will come next. But for now, let's change our code so that it makes use of the experiment framework. To do so, let's click on the fourth IPython notebook in this TensorFlow directory. This is the one titled d_experiment. This introduces the distributed training. The beginning of this notebook ought to look pretty familiar. As before, we have the same read dataset methods. We have the same methods to get the training, validation, and test data. No real changes here. But where it gets interesting is down below. And this is where we introduce the tflearn.experiment object. This experiment object starts out with an estimator. So the experiment is a harness of sorts. It needs to take in a model object. This is a linear regressor as before. In this particular example, we are not going to tweak that model object based on any input parameters, but as we shall see, this estimator object can be tuned based on input configuration files. That process is known as hyperparameter tuning. Once again, we have to pass in functions to get the training and the validation data. This is once again familiar. Then here is something new. Notice this eval metrics argument. This is a way for us to tell our experiment harness how to determine which of the models that it has trained is the best. So here we've got to specify a metric. That metric is a streaming root mean squared error metric. If you're wondering why the word streaming appears there, it's because this metric needs to preserve its value across different runs, across different batches, and across different epochs of the experiment. Notice how the use of this tflearn.experiment harness has abstracted us from the actual mechanics of invoking fit or predict or evaluate on our model object. All of that is done by the harness. And down below are a couple of lines that are maybe the most important in this entire IPython notebook. Notice how we invoke a runner object. So we invoke the run method on some object, that is the learn underscore runner. That is going to take on the responsibility of running the test harness that the experiment is. This runner object could be a local runner or it could be a distributed runner which would carry out the training on the cloud. This is something that we are going to see when we talk about ML engine in just a little bit. For now, this learn runner is a simple local runner. It goes ahead and evaluates our model locally and it gets an RMSE on the validation data of 9.1. As an aside, before we get to a conversation of distributed training and prediction, just check out how we can carry out monitoring using TensorBoard. This ought to look pretty familiar. We just start TensorBoard, we point it at the directory where we had saved the model, that is the same output directory that we passed into our experiment object. If we open up TensorBoard, we can find the usual familiar graphs which show a decline in the root mean square error as the number of epochs increases. This is the loss function, and down below is the RMSE. TensorBoard is pretty familiar to us by this point. Let's move on to the next phase where we perform distributed training using Cloud ML Engine.